Eins, zwei. Hören Sie mich? Okay. Ladies and gentlemen, may I have your attention, please? Please take your seats so we can start in 1 or 2 minutes. Ladies and gentlemen, what a wonderful day. Welcome to Vienna. My name is Daniel Veselka. As representative of the Federal Ministry of Education, Science and Research, and as today's Master of Ceremony, it's my great pleasure to welcome you all here in Vienna. In my capacity as Director for Basic Research and Research Infrastructures in the Ministry, I participated in all the ICRI conferences in Copenhagen, in Athens, and in Cape Town. These were all great and excellent events. It's therefore a special honor for me to guide you through today's 4th International Conference on Research Infrastructures. Together with my great team, and on behalf of the sponsor and co-organizer, the European Commission, we hope that you will experience a delightful stay in Vienna and an exciting conference. Our aim was to offer a diverse and interesting program with first-class talks and presentations, with workshops, and of course a lot of room for discussion and personal exchange. At the end of today's program, if you have some spare time, please stay in the room. We have a special Viennese surprise for you. And tomorrow, please do not forget that we start at 9:30. This conference is part of the Austrian European Union Council presidency. And therefore, we start now with a short film clip. Enjoy.
To achieve something great, it needs talent. In every country, challenges need to be faced. Pioneers working hard to perform best. They never give up. Because there are others who do the same. And if they play together, everything is possible. We stand up against global warming. Defeat hunger. Advance technologies to improve our lives and empower the talents of tomorrow. Together, we play a powerful symphony that is going to change the world. So let's advance Europe together.
If we play together, everything is possible. Let's advance Europe together. I'm not in the wrong conference, I know. I'm in the Global ICRI conference. So our motto is therefore, the first slide please, advance the world together. Welcome to Vienna again. Now it's a great pleasure to introduce the first speaker, Mrs. Barbara Weidgruber, the Director General for Scientific Research and International Relations in the Federal Ministry of Education, Science and Research. Barbara joined the Austrian Ministry in charge of higher education and research as head of department in 1994, later became Deputy Director General for Higher Education, and in 2010 she was appointed Director General for Scientific Research and International Relations. Besides her tireless commitment to all the agenda of a Director General, with all its multifaceted fields of responsibility, she represents Austria in numerous committees, including the Task Force for Research, Technology and Innovation of the Austrian Federal Government, the Austrian Fulbright Commission, the Austrian Marshall Plan Foundation, the European Research Area Policy Forum, and the Scholarship Foundation of the Republic of Austria. Barbara, please, the stage is yours.
Thank you, Daniel. Excellencies, distinguished guests, as Director General for Scientific Research and International Relations at the Ministry in charge of coordinating the Austrian presidency of the Council of the European Union in the field of research, it's a great honor and a pleasure for me to welcome you all to the 4th International Conference on Research Infrastructures, co-organized and co-sponsored by the European Commission and co-organized with the Austrian Ministry of Education, Science and Research. After Copenhagen in 2012, Athens in 2014, Cape Town in 2016, Austria is really honored to host the global conference in Vienna during the Austrian presidency of the Council of the European Union. Let me start by conveying to you the best wishes of our Minister of Education, Science and Research, Heinz Fassmann, who will address you tomorrow morning together with the Commissioner for Research, Science and Innovation, Carlos Moedas. I hope that you will all enjoy your stay here in Vienna and in Austria, a country full of history and tradition, as you can see at this conference hall and in the location, which is in the Imperial Palace. For over 600 years, this palace was the residence of the Austrian emperors, the Habsburgs. They reigned here from the 13th century until the end of the monarchy in 1918. Still, at the same time, Austria is a country of science and technology, research and innovation. We have a rich and diverse higher education, research and innovation landscape with 22 public universities, the main research performing institutions in Austria, 21 universities of applied sciences, and some very small private universities. The Austrian Academy of Sciences is not only a learned society, but Austria's central non-university research institutions with 1,700 employees dedicated to innovative basic research. And modeled after the Weizmann Institute, the Institute of Science and Technology, established only in 2006 as an interdisciplinary frontier research performing and PhD granting institution, has by now over 700 researchers from 65 nationalities, also focusing on basic research in life sciences, physical sciences, mathematics and computer science. Since 2005, Austria has more than doubled its research expenditure and increased its R&D intensity from 2.3 to 3.19% of our GDP. Our target is actually 3.76 by 2020. Our R&D rate is second highest in the European Union after Sweden and the 7th highest in the world. We are a strong innovator according to the European Innovation Scoreboard, with key performance indicators improving significantly over time, especially international patent application and international co-publication. With a vibrant academic sector that is very much open for cooperation with industry, we provide an excellent collaboration with the entrepreneurial environment, also for R&D intensive companies. We rank second in cooperation with large businesses and third with SMEs. Moreover, in January this year, the new government, which only was elected at the end of last year, agreed to increase a tax incentive for business R&D from 12 to 14%, which adds actually to the research-friendly entrepreneurial ecosystem even more. And we are well embedded in the European research area, and our researchers compete well in the EU Research and Innovation Programme Horizon 2020, so well that we rank second jointly with France after Belgium, relating the success rate in the framework program. Still, the challenge that Austria as a small country is facing, and this is probably one we share with many countries in the world, is priority setting. And this, of course, is especially true when it comes to the issue of research infrastructures. One of the key considerations in the specific nature of the research infrastructure is it cutting-edge technology? Will it be a key infrastructure, key enabler for science and the research in a certain area? Which type of access, which type of services will the infrastructure provide? And do we have the potential? Are we strong enough in the national scientific community to make use of it and to make the best possible access to certain infrastructures? Governance and organizational structure, as well as financial models, efficient, transparent, fair, and legally and economically sound, are of course just as relevant. Austria puts a special focus on fostering diversity and cohesion across Europe in a truly European research area. So a membership contribution model should be affordable also for very small countries and less wealthy regions. And the same is true, of course, when it comes to international cooperation. Apart from the participation in multilateral research infrastructure, it is also an important question which research infrastructures to establish on a national level. Concerning large-scale research infrastructures, again, there is more than one aspect to consider. You either have a specific niche, or you know that you have a very great potential and expertise within the country if you want to build up such an infrastructure. Just some examples of recent years. At the Medical University of Graz in Austria, there is one of the largest tissue biobanks in Europe, which is a very active partner in the European Biobanking Research Infrastructure, VBMR ERIC. This is also the reason why Graz then qualified for being the host site of this European Coordination Office of the VBMRI ERIC. I would also highlight the so-called DREAM project, a dream come true, the Danube River Research Management, a hydrology research infrastructure at the river to analyze the impact of river management measures. This is a transporter cooperation with Slovakia, the Czech Republic, and Hungary, and helps to implement the European Union Danube Region Strategy. And last but not least, the synchrotron facility Med-Austron, which is a proton and ion particle accelerator with dual benefit. On the first hand, first state-of-the-art radiotherapy center for cancer treatment, but also a research infrastructure for non-clinical research, radiation physics and radiation biology, for instance. So rapid technological and scientific developments require ever stronger and at the same time more costly replacement cycles of high technology research infrastructure. And for the international competitiveness, the provision of research infrastructure is just as essential as the adequate pool of talent. It is the nature of science and research to investigate on the forefront and to develop technologies further and further. New findings, rapid technological development create a constant interest, at least on the side of the researchers and within the scientific community, to establish new cutting-edge infrastructure and to continuously upgrade existing ones. As all our national budgets are limited, we have to be interested to invest in a strategic way. Here comes also the international dimension in place. Very large, technologically highly complex, single-sided research infrastructures can best be established when expertise is pooled and costs are shared jointly in a transnational, transcontinental context. To mention only one of the manifold international examples, the ALMA radio telescope based in Chile, which is funded by the US, Canadian, Japanese, Taiwanese, South Korean Science and Research Foundation, as well as the European organization ESO. By establishing international networks of distributed research infrastructures, access to nationally based infrastructures can be improved, an overall pool of samples and data can be increased, the comparison of different data sets facilitated, the quality of samples and data standardized and improved, and of course, training and expertise can be enhanced. As much as international collaboration within the field of research infrastructure is needed, we are still facing many challenging questions. While international collaboration comprises all the aforementioned positive aspects, it increases at the same time the complexity of issues like governance, operational, technical, and financial aspects. Therefore, this conference provides a perfect forum to reflect on and discuss such aspects. Our conference builds on the outcome of the last conference in South Africa and will focus on a number of issues from internationalization to human resources to fostering diversity and enhancing the societal value of research infrastructures. Yesterday, the Austrian EU presidency hosted the launch of the so-called ICRI Roadmap, European Strategy Forum for Research Infrastructure, aiming at an interoperable, sustainable research infrastructure ecosystem in Europe. From my point of view, this is a solid basis for excellent collaboration with partners from across the world. Therefore, let us remind us again on the global motto of our conference, Advance the World Together. Let me conclude by thanking the organizers of this outstanding event, in particular the International Program Committee, chaired by Ales Fiala from the European Commission, Daniel Weselka from our ministry, as well as the local organizing team headed by Sabine Hertgen, also by my ministry, and maybe we give them some applause. I wish you all an enriching stay here in Austria on a personal level, but more so on a professional level, and look forward to stimulating debates and many suggestions on our way forward, so that we will have some tangible results on Friday in the concluding sessions where I will have the privilege to take part in again. Thank you so much.
Dear Barbara, thank you so much for your introductory words and your kind words on the organization. Thank you very much. Now I am pleased to introduce to you Mr. Jean-David Malo from the European Commission, the Director of the Directorate for Open Innovation and Open Space. Jean-David joined the European Commission in 2001 as a member of the Directorate General for Research and was involved in the development and design of funding instruments, funding schemes, etc. for the Framework Program 6 and 7. Afterwards, he headed and managed various units at the European Commission in charge of, for example, regional aspects of the framework programs or innovative financial instruments. In 2017, he was appointed Director of the Directorate for Open Innovation and Open Sciences, where among many others, he is in charge of the long-term sustainable investments for research infrastructures. Jean-David, please, may I ask you to the stage.
Excellencies, Director General Weidgruber, dear Barbara, distinguished guests, ladies and gentlemen. First of all, allow me to share with you some support words from our Commissioner Carlos Moedas and our Director General Jean-Éric Paquet, who are not able, due to other commitments, to be with us today, but as they consider this area of key importance for Europe, they will be there tomorrow morning. and you will have the chance to be in touch with them. It's a great honor for me to be here today in a very exciting week. And I would like for this to warmly thank the Austrian presidency of the Union, and in particular Barbara Weidgruber, for the excellence of the organization of the various meetings. You mentioned yourself in your speech that earlier this week we had the launch of the Roadmap 2018 of the European infrastructure. Today is ICRI. In the meantime, an impressive number of satellite events took place. Just to cite one, the signature this morning of the charter of the League of Advanced European Neutron Sources. So a very exciting week and a very exciting week for Europe and the world. It's, as you said, Barbara, already the fourth edition of ICRI, which started in 2012 in Copenhagen and was followed by Athens in 2014 and then in Cape Town in 2016. But just allow me to remind you that the European Commission already started to organize this kind of international event already starting in 2000. And the first time it took place not in this dimension, not so ambitious as this one, but it started in Strasbourg. So in other words, we could say that after 18 years of international events on research infrastructures, ICRI has now reached adulthood. And when you are becoming an adult, by definition, you have the right to be ambitious and you are full of promises. This is reflected in the sessions that have been prepared by the program committee of the conference that I would like to warmly thank. And we will touch upon all the important challenges pertaining to research infrastructures today and tomorrow. And in my opening speech, I would like to share with you what are those challenges and maybe to give you a kind of a roadmap for these 2 days. What are the challenges and what can we expect from this conference? Maybe we could wrap up this under 6 or 7 main topics. First one is the need for developing a shared vision on global research infrastructures. Research infrastructures are costly, both to construct and to operate, and consequently, very rational decisions need to be taken in order to ensure that the limited resources available are spent in the most efficient manner. While the issues that they are tackling are very often of a global nature, the decisions that lead to the construction of research infrastructure are often taken at regional or national level. An international dialogue between the founders of research infrastructure is therefore absolutely necessary to ensure coordination and sharing of good practices, as well as to develop a long-term vision of global research infrastructures. A number of initiatives has also been set to promote an international dialogue on research infrastructures, such as the work conducted by the Global Science Forum under the OECD umbrella, or the activities of the group of senior officials on global research infrastructures. But it may be time now to reflect on the effectiveness of this initiative and on their relevance with respect to the challenges faced by research infrastructures worldwide. The second issue is relating to internationalization of research infrastructures. The consultation on the long-term sustainability of research infrastructures, which took place recently in Europe, has evidenced the importance of increasing the visibility of the European research infrastructures and of the services, to the international communities of users. This has, however, consequences on the way research infrastructures operate, and in particular on the condition put in place for their transnational access and the sharing of results. Therefore, one question that we should ask ourselves is how can the national authorities, their relating funding agencies, institutions and researchers could address successfully these challenges that I just mentioned. A third group of issues are relating to human resources in the development and the use of research infrastructures. Research infrastructures need to integrate multiple competencies so as to offer to the scientific community those services that are expected. Ensuring the excellence and sustainability of research infrastructures requires by nature flexible staff members who can integrate well into multicultural and multidisciplinary work contexts, highly competent facility managers, and operators with advanced technical skills. Increasingly, research infrastructure also requires individuals with the skills required to design and operate cutting-edge data technologies, manage large-scale research data collection, and interface with a broad range of e-infrastructures. What are therefore the gaps and future needs in human resources capabilities for research infrastructures? How can we address them? What kind of training and skill development activity should be considered? The fourth group of issues are dealing with fostering diversity and overcoming inequality. Indeed, also, research infrastructures are essential components of the research and education ecosystems. Not all countries and communities can contribute to their development and take advantage of their use equally. Differences in size, financial capacity, human resources and education levels, among many other factors, limit engagement and participation. So how can we overcome inequalities in the development and use of research infrastructures? And how can we identify practical measures that can foster this diversity in their use? The fifth group I would like you to consider is relating to the enhancement of the societal value of research infrastructures that Barbara mentioned also in her speech. Research infrastructure, as you know, creates societal value in a wide variety of ways that go well beyond the production of scientific knowledge and the direct economic impact. They are, however, distant from the actual value resulting from new scientific knowledge. Assessing and communicating the societal value of research infrastructure is a challenge, but also a necessity in order to convince policymakers and public authorities to make long-term investments on research infrastructures. Another group of issues, and it's certainly one of the most prominent in the last days, at least in the debate taking place in Europe, is relating to research infrastructure and data. Research is increasingly data-driven, and research infrastructures are becoming data factories that produce ever large volumes of increasingly complex data. Research infrastructures have gained experience in the management and exploitation of data, and while significant advances are being made in making research data available to researchers, concerns around data quality and reliability remain. How can we ensure the quality and reliability of the data produced? How can we design and implement data management systems that can be trusted, and this especially within an open science context? These are all the questions that I would like to hear the speakers, but also the participants from the audience address in the plenary and parallel sessions that will take place in the coming 2 days. It's an ambitious agenda, but we have the chance to have today in this room very experienced, very skilled, very valuable people. And we should use the opportunity of these 2 days to reflect on these key issues. Let me conclude by stating that whatever the answer to all these issues could be, there is a pressing requirement to improve cross-border cooperation on research infrastructures, sometimes overcoming political difficulties that could prevent an open international dialogue. The variety of institutions represented here today, coming from a multitude of countries from all continents, confirms the importance of discussing research infrastructure at international level and clearly acknowledge the role of ICRI as the main gathering for research infrastructure stakeholders. I wish you all a very fruitful discussion and look forward to the conclusion of this conference.
Thank you, Jean-David. Thank you very much for your important remarks. Now, ladies and gentlemen, distinguished audience, for something completely different, or not really completely different, but let's go into the real thing. Do you remember September 14th, 2015? No? Do you know what GW150914 means? No? May I help you a little bit? On September 14th, 2015, the entire planet was shaken by an event which took place more than 1 billion light years from Earth. You still missed it? According to the LIGO webpage, the peak gravitational wave power, gravitational wave, radiated during the final moments of the event was more than 10 times greater than the combined light power from all stars and galaxies in the observable universe. Can you imagine? This remarkable discovery marks the beginning of an exciting new era of astronomy as we open an entirely new window on the universe. The whole story, and it's a breathtaking story, is now presented by Fred Webb and Livia Conti. May I ask you to the stage? Fred and Livia? Here she is. The stage is yours. Enjoy. Okay.
I need the slides. Okay. Right. So thanks to the organizer for inviting us. We talk about gravitational waves, and they were already introduced, but let me repeat. I'm sure that you already are familiar with the words gravitational waves, and there were at least 2 instances that you might have heard of gravitational waves, reading in the news or watching the news. The first time was in February 2016, when the LIGO and Virgo collaboration jointly announced to the world the first detection of gravitational waves. Maybe you have already seen this picture that shows the first signal. That was the first detection that was made, and this signal originated from the merger of 2 black holes. Then, in autumn last year, you might have heard again in the news of gravitational waves when the LIGO and Virgo collaboration jointly announced the detection of gravitational waves from the merger of 2 neutron stars. And that is exemplified in this picture that you might already have seen. And there was a birth of the multi-messenger astronomy. Now, what are gravitational waves? Now, they were predicted a century ago by Albert Einstein in the context of general relativity. Now, it's not, this is not, of course, the time, the occasion to explain general relativity, which is a very complex theory. But let's try to consider gravity as theorized by Galileo and Newton. There is a problem with this. The Newtonian gravity was a very powerful theory that allowed lot of progress, both on the scientific and technical aspects. But there is a main problem with this theory of gravity, is that if you have a mass here, now in the whole universe, immediately the gravitational field of this mass is felt everywhere at the same time. And this is, of course, is a problem, as recognized by Einstein, because no information can travel faster than the speed of light, which is finite. So there is a problem, and Einstein solved this problem developing the theory of gravitational wave of general relativity. And within this theory, gravitational waves are predicted, and they are usually referred to as ripple in the space-time. But let's move to the following. So within the context of general relativity, gravity is explained as a manifestation of the curvature of space-time. And if you have a concentration of energy and density, energy and matter, you bend the space-time. Space-time is a concept where space and time are almost the same thing, because of and the connection between the two quantities is given by the speed of light, which is finite, and connects the space and time. And if you have a bent space-time, you can explain gravity, and you can explain, for instance, why the planets move around the sun, and not only masses are feel this curvature of the space-time, but also the light, as shown in the picture on the left. But space-time cannot be deformed only in a static way by matter and energy, but also dynamically. Okay? So if you have, can you repeat the animation, please? Is the animation on? Yes, please. Thanks. So you have two massive objects that move around each other. Then this deforms in a dynamic way the space-time, and this dynamic deformation propagates to the universe, and this is what is called gravitational waves. But the space-time is very stiff, so you need a lot of energy to deform it. And so when we look for sources of gravitational waves, we look at the sky, we look at the universe, where very powerful objects exist, and they are also very interesting to study. And for what we will, so we have different sources of gravitational waves, and for what we, and different sources has the different time scale, and so different frequency. And like the electromagnetic spectrum is has a very wide frequencies range. And for what we will discuss now on, we consider only sources that have a characteristic time of order of a second or a millisecond. And these are the kind of sources that can be detected with instruments on ground, and this is what we will talk about. So how can we detect gravitational waves? So let us consider what's the missing? Let us consider a system of a test particle in a ring. Let's say that this type, this one. Then when a gravitational wave crosses this ring of particles, for instance, it propagates perpendicularly to the screen, this ring changes shape. It's not round anymore, and there is an oscillation, and in one direction the ring is elongated and shrinked in the perpendicular direction, and then this changes periodically as long as the gravitational wave passes by. And so the idea to how can we measure then this effect of deformation of this tidal motion, how we can measure this with the ideal instrument is an interferometer. Interferometer essentially consists of a laser beam that is divided in two arms that propagate in perpendicular directions, and then the two beams propagate on these arms, and then they are each is reflected by its own mirror, and they are recombined at this beam splitter, and then observed at a photodetector. And because of the passage of the gravitational wave, you have the light beam spend different time in the arms, and so you can detect, and this produces signal that we can detect. But let me emphasize this, what is written here, that is important for the infrastructure, and will be later discussed on. The deformation is the signal, okay? The deformation of the ring is the signal, so that it is the quantity that you can measure, okay? Is the observable. Then to increase the signal that you can measure, you have to you have either to have a very big gravitational wave, but this is given by nature. It's not under our control. So the only thing we can do to increase the signal that we can measure is to increase the size of this ring. Okay? The size of the interferometer. This must be very big so that the signal that can be measured is large. But these are the animations. Now I find. Okay, this is the effect of the passage of gravitational wave and the idea of measuring this with an interferometer. So let me once again repeat the concept of how an interferometer works. So we have a laser source and which output a laser beam. It is shown as a green and as a red line in this picture. Then you have a beam splitter that divides this beam in two parts that propagates along perpendicular directions, and each beam is reflected by a mirror and then goes back. So goes back, and they recombine here where I put my eye, or more safely my photodetector. And what happens if the two arms are equal? Then there is a so-called destructive interference, and so I see no light, so dark here, nothing, no light. But if there is a gravitational wave that changes the relative length of the two arms, then I see some light. There is some constructive interference, and so there is some light. So in this way, I can convert this mechanical signal, let's say, so this change in the arm length with into a light signal that we can measure. Okay. Then, as I told you that we need to have a big. So it is important to increase the signal, so to have a big infrastructure. But this is not the whole story, because what you really have to do is to maximize the signal to noise ratio. So you want a big signal and little noise. And, there are many noise sources that plug this kind of instruments. Some are very fundamental ones, like the so-called shot noise, so the error that you do in measuring the numbers of photons that are arriving, and the radiation pressure noise. But there are some more technical noises, like the thermal noise of the mirrors. So the atoms that constitute the mirror are not frozen, but they vibrate, and this makes uncertain the average position of the surface mirror. And this kind of noise, and the noise, for instance, of the seismic noise, this kind of noise are can scale with the length of the interferometer. So if you increase the length of these arms, and they are order of a few kilometers, then you increase the signal to noise ratio. And this is very important. Now let's move to what is more specific to this conference, so the infrastructure. So the detectors, the instruments that detected the waves are the two LIGO instruments in the US and the Virgo instrument, which is in Europe. And they were both proposed in 1989. At that time, they were very clever, and Fred was one of them, to build, to project, to propose infrastructure that was that could house evolution of the instruments, so that could be used also for new ideas that might arrive later and did arrive later. So this was a birth in 1989. Then was in 1997 an important fact that the LIGO established the International LIGO Scientific Collaboration, and at the same time, more or less, the LIGO and Virgo decided to acquire data in the same data format, and this was very important, so that this allowed a real collaboration, and this was a decision that was taken back in the 90s that is very powerful nowadays. And then we had, in the decade 2000, we had first data taking of initial LIGO and initial Virgo, and then the advanced version of these interferometers, using the same infrastructure but improved instruments, started operating in 2015 LIGO and 2017 Virgo, and indeed in 2015 we had the first detection. And then I switched to the next speaker, Fred.
Thank you very much, Livia. So in 1989, we had a challenge. It's said that a good athlete runs fastest to the ball. But to be a great athlete, you have to run to where the ball is going to be. And so the challenge we had in 1989 was to guess where the scientific ball would be landing in the early 20th century. And I'll confess that things in reality took about twice as long as they took in our imaginations, but at least we got the right century. And so LIGO was designed to be able to very confidently make detections, and because of the smallness of the signals relative to the natural noises that we experience all the time due to seismic motion or due to just motion of the components of materials, we knew that we would need to be able to see identical signals in at least two detectors to know that it wasn't something going on in the detector, but it was due to an astrophysical event. And so there were these two detectors that the US committed to build. But we also knew that for astrophysical objects that contained matter, when they would give off gravitational waves in large cataclysms, the amount of energy released would also tear matter apart, and there would be lots of free charges, and those charges would radiate across the electromagnetic spectrum, from gamma rays down to radio waves. And it would be very important to be able to point those electromagnetic telescopes and space telescopes to where the collision occurred. And so we had to be able to point to a direction. And the problem is that one of these detectors is no more directional than the microphone in front of me. And to really know where a sound came from, you need to do the same thing your ears do, is you need to realize that the sound will arrive. If the noise comes from the right, the sound will arrive first on your right ear and second on your left. Okay? But to identify an object anywhere in the sky, you needed at least 3 detectors. And we knew that Europe was planning to build a similar type of detectors. There were two proposals for different detectors in Europe. We didn't know exactly where they would be, but we knew that the perpendicular to that baseline ought to point to Europe. And so that heavily weighed the layout. The other thing we knew was that we would need a very large collaboration of scientists to be really able to do justice to the storms of data that would eventually be coming in. And so this is a map that shows the member institutions of the LIGO scientific collaboration. It's pretty geographically distributed, but you'll notice a north-south asymmetry, and unfortunately we still do not have collaborators on the continent of Africa, and we hope that changes in the future. Virgo is a collaboration also of about 20 laboratories in 6 European countries. The map is shown over here. And it involves more than 280 physicists and engineers. The LIGO scientific collaboration is much larger. It's about 1,250 scientists and engineers. And these are the institutions that fund the Virgo detector, and here's a nice visual of some of the people who make these detectors run. We also knew that eventually, and this was envisioned in the original proposal in 1989, eventually to do justice to the science, there's not just the location of objects in space, but gravity waves have polarizations just like light has polarization. They're different topologically, but it's the same general idea. And to really milk all of the science out of making observations, we really would need an international network of detectors. And so we relied on the countries of the world getting together and building this network. And I'm happy to report that not only do we have the network of 3 of the two US detectors and the Virgo detector, but we now have under construction the Kagra detector in Japan, which is going to be a 3-kilometer detector. The 2 LIGOs are 4 kilometers. Virgo is 3 kilometers. Kagra under construction is an underground detector, will be 3 kilometers. And we hope by the end of this year, construction will start on LIGO India, which will be a 4-kilometer detector of the same design as the LIGO detectors. So, come the 21st century, the ball arrived, and it was the merger of 2 black holes was the first signal that was seen on September 14th of 2015. And so we detect the actual what we call it a waveform. It's a time series. One could think about it similar to an electrocardiogram signal. And just as the squiggles in an electrocardiogram can tell a lot about the health of your heart, these squiggles tell us a lot about what's going on at the source. And so here we show the reconstructed waveform from that first detection, and the way the waves changed, that evolution of the phase of the wave and the frequency tells you something about the masses that are orbiting. How smooth the wave is, or whether there's modulation of the amplitude of the wave as the frequency rises, tells you something about the spins of the objects, which can tell you how those black holes formed and got into a binary black hole system. Those highest frequencies of the wave tell you the sizes of the objects just before they merge into one. And then the final squiggles tell you the ring down frequency, and that Q number is the mechanical quality, how long it rings. And that ringing is a very specific prediction of Einstein's theory of relativity, we didn't have quite the signal to noise yet in the detectors to make that out. So those first detections of black holes that were made were very dramatic and were able to test general relativity, our theory of time and space, in the most extreme places in the universe. And so that was really dramatic that the agreement was so good. But then that opened up the possibility that the theory could now be used to explore, the theory confirmed exploring the most extreme states of time and space could now be used to explore the most extreme states of matter. And this occurred on the 17th of August, 2017. And that was the observed collision of two neutron stars. So neutron stars are stars that each weigh more than our sun, but are about the size of Austria. About the size of Vienna. And so they're very compact objects. They weigh millions of tons per teaspoon of matter. And they give off a very powerful electromagnetic signal as well as the gravitational wave signal. So what you see in this middle diagram is the rising frequency over time as the two black holes radiated gravitational waves and their orbits collapsed, and here they merged at time labeled t equals 0 here. And then within 2 seconds, an X-ray pulse was picked up by the Fermi satellite, and that was confirmed at the same time by a signal in the integral X-ray satellite. And so very quickly, the gamma rays were picked up, but this was just part of a cascade of radiation that went on for months. In fact, there was just a paper published this week in Nature showing the jet, the electromagnetic acceleration of particles. That jet has just appeared, and the paper's just been published in Nature. So it took about a year for that jet to fully plow through the rubble that was created by this collision. This was the first localization of a source of matter, extreme states of matter, that was done. And so this diagram shows you the power of the LIGO detectors combined with Virgo. So we were able to identify a small patch on the sky, much better than the satellites could do, a fairly small patch on the sky, and also we knew the depth of that patch. So the astronomers with optical tools were able to know that there were about 50 candidate galaxies that they had to look for to find the source. And in fact, when they pointed in that green region here, they in fact saw this image of this galaxy. Here's an image 20 days before, and you'll notice that there's a new, very bright object that appeared. And that is the radiation from this nuclear collision, which solved a riddle, which is where the gold in our wedding bands comes from. It comes from neutron star collisions. So how do we take this into the future? It winds up, this is a highly leveraged field. If you can reduce the noise, then you can see twice as far out the same event occurring. But that means that the sphere of possible galaxies in which you could see that event has increased by a factor of 8. So we're incredibly highly leveraged by improving the sensitivity of the detectors. And it appears possible, and people are doing the studies right now, it appears possible to go and look for these black hole collisions and neutron-star collisions out to the edges of the visible galaxy when the first generations of stars made these objects. And so we know that the rate of events now is approximately 1 per month. But we know that somewhere in the universe, the rate of these black hole collisions occurs several times per hour. And we believe the future will unravel away with new facilities to track down every single one of those events. I'm sorry, we jumped ahead a bit. Okay, that's what we wanted. So there are two concepts on the drawing board right now. One is called the Einstein telescope. So Europe got a head start on us in the US in looking at what might be the next generation of facilities. And a few years ago, a design study was done for something called the Einstein telescope, which is an underground facility with arms of 10 kilometers, but arranged in a triangle. If you use a triangle instead of an L, you can recover both polarizations, whereas an L only gives you one polarization of the gravitational waves. A more recent study has just been funded in the past month or so by the National Science Foundation in the US to look at another detector called Cosmic Explorer. Cosmic Explorer would have an L shape, but it would have 40-kilometer arms. And at that type of size, the facility limits would allow you to be able to go out to basically a time when the universe was 20 times smaller than it is today, when the first generations of stars were created to look for the black holes and binary neutron stars from that era. So we'd like to end on some personal reflections, these reflections right now that I'll speak to are mine. It's not that Livia and I disagree, but we're different in age and experience in the field, so we have somewhat different perspectives. So the first is that there were dozens of reasons not to attempt to build these gravitational wave detectors back at the time in 1989 when they were proposed. Many of the features were just on a grand scale. They required cooperations internationally that were quite uncommon. And so you could just think of hundreds of reasons, and various people expressed them to me at one time or another. But there was one reason to do it, and that it really was good for science to propel science forward. It was also obvious from the start that the facilities and the generations of detectors that would be needed to make first detection was a decades-long project. So 30 years of experience to be able to build these wasn't a total surprise to me. We thought we might get it done in 15, but that's what it took. It also took villages of people, not a village, but many villages of people across the world to really do all the work that was needed, working in unison to be able to do it. And it will take even larger numbers of villages and hopefully more diverse villages in the future to build the next generation of facilities. The scientists and engineers who build these and operate them are not the owners. The owners are the people who pay the taxes internationally that get these things built. And that's a very important thing that we have to remember. And so a lot of the effort in LIGO and Virgo and other places across the world in gravitational waves is in the field of outreach and education. And then finally, very personal for me, is that no deed goes unpunished. we've now become one of the driving forces in astronomy. And so the astronomers across the world are constantly wanting to know exactly what month do we go into running again so that they can coordinate their facilities and the time allocation of scientists internationally to use their facilities. I'll turn it over to Livia for her comments.
Okay, then yes, I split the comments in what the feeling of the scientist before detection and after the first detection. Yeah, I'm short. So, so before detection, the field was hard, let's say, because you had to be really convinced that this was a good science. The goal was worth the big effort that was needed. And the second point that I want to make is that it is linked with the first one. It was difficult because also because of the intrinsic difficulty of detecting gravitational waves, because the signal is really tiny and the noise is huge. But this reflects from the life of the scientist and the fact that you don't publish many results with a high citation index. So it is difficult to publish a lot. And we are often compared to people in the different fields, experimentalists in, for instance, in high energy physics, the people who work at CERN, that have a very different, much larger publication rate and citation index. So it was really difficult, both because you had to be convinced of what that you could achieve in the end the first detection, and you have to survive against this poor, low publication rate. And there was also little space for an R&D on new ideas, because all the focus, all the effort had to be on building these instruments, and which is not trivial. I hope you understand that they are very complex instruments. But this situation has changed a lot after detection. So after the first detections, then there is an increased interest, for instance, in the public. So everyone to know about gravitational waves. So there's more and more scientists that are involved in the outreach activities. And we, as already Fred told you, we believe it's very important to reach to the people and which are the owner of the facilities. And we had also experienced an increased interest among colleagues, which resulted in opening of new positions and new collaborations. And then we had, now we feel more freedom to work on the next step. And the next step is you want to listen to the universe better and further. And so we need to overcome the limits of the existing infrastructure. And okay, these are my comments, final comments. I think we are finished.
Thank you very much. Thank you very much, Livia. Thank you very much, Fred. Breathtaking, isn't it? Great science, great research infrastructure, great people, and a great team. More than 30 years of dedication. I loved it. This is basic science at its best. I like that spirit, to go where no one has gone before. So let me hand over now to the chair of the first plenary session, to Jean-David Malo from the European Commission. The floor is yours. Thanks again.
First of all, many thanks again to Professor Rubb and Professor Conti for their very inspiring presentation. In this first plenary session, we would like to dedicate a bit of time to one of the key issues, which is the sustainability of research infrastructures on the global arena. We would like to use the chance we have to have among us very valuable and skilled people, very experienced people, in order to discuss with them a number of policy developments, what they have learned towards their own experience, what kind of strategy could be discussed, explored in order to tackle this important issue of sustainability of our research infrastructure at global level. For this, I have the chance to have with me 7 very valuable persons. I would call them the 7 magnificent. And if you allow me, I just would like to call them to join me on the stage right now. Phil Miawara, as the Director General of the Department of Science and Technology in South Africa. You can applaud him. Karina Angelieva, the Deputy Minister for Education and Science in charge of portfolio on research and innovation policy as well as structural fund in Bulgaria. We have the honor to have with us also the Minister of Science in Montenegro, Ms. Sanja Damjanovic. Hello again. Sean Doherty, the Director of the Atacama Large Millimeter Array, ALMA. Tony Donnet, the Chair of Aeroforum. Ilaria Naldello, the Executive Director of the European Marine Biological Resources Center, which is a very recent ERIC. And finally, Luca Pezzatti, the coordinator of the S3 project ERINS, European Research Infrastructure for Heritage Science. So, ladies and gentlemen, first of all, many thanks for having accepted to participate to this first session. I would like to start with you, Phil, just to ensure continuity with the previous ICRI, because as it was recalled by Director General Weidgruber and myself in the introductory speech, the previous ICRI took place in your country, in Cape Town, in 2016. This conference, these ICRI conferences, bring together stakeholders and policymakers on research infrastructure, and now are truly events with hundreds of participants coming from different countries, as it is also demonstrated today. I have a first question for you. Looking back at ICRI in 2016, what are the key messages identified in Cape Town that should be of interest to the participants of this edition in Vienna, just to pave the ground and to ensure indeed that we will have a continuity in this conference? And according to you, do you consider that they are still actual? Do you see a number of progress, or do we still have a number of challenges to tackle? Please.
Thanks very much. I had a presentation that I had prepared. So if we go to the next slide, and I'll come directly then to the question that you've asked. But before I do that, could I just express my sincere thanks and gratitude to the Commission and the Ministry here in Austria to ask me to come and say a few words about how we saw the ICRI 2016 in Cape Town. So I will not talk about this because these were the objectives, which I think are still almost similar to the reason why we're here today. These are just some of the pictures of the people who were involved in the ICRI. I'd like to draw your attention to the minister at the time who launched our own South African roadmap in South Africa, which was, of course, inspired by the ICRI roadmap here in Europe. And then, of course, you see the minister was also interacting with young people to try and inspire them to get involved in some of these research infrastructures before. Some familiar faces, I think, in Europe, myself, and then some people in the meeting. But this is what you've asked me, moderator, to talk about. One of the discussions that came in Cape Town is that global research infrastructure are very, very important to try and address some of the poverty, inequality, and unemployment. And maybe in Europe this is something that is fairly trivial, but we spend a lot of time trying to link the role of global research infrastructure in meeting the societal problems. We, in Africa, for instance, recognize that if you're dealing with issues of climate change, they would have huge impact in agricultural sector, which a lot of countries in Africa rely on. So we then had to look at climate change, energy issues, and how the global research infrastructure would address some of these. Water, energy, and food nexus, for instance, was one of the key messages that came out of this. That, of course, it addresses the global science. The previous presentation, for instance, speaks about this, and then I will show one specific example at the end. And then it provides space for international partnership. It's also a catalyst for development. We pick that up, that you shouldn't assume that by having global infrastructure, it is completely divorced from development. And I will share an example in our own country where this has played a very, very important role. And then, of course, it is a catalyst for training highly trained people. And then, of course, it attracts interest from public and learners in science. The second message, which has already come from some of the opening remarks, is that we are a data-driven society, so we had a lot of discussion around this, and that the research infrastructure sometimes is seen as a catalyst for disruptive technologies. Most of you, of course, today take the World Wide Web as something that is a standard, but it came from, I think, a global research infrastructure. And that we need to start thinking about how we manage data. You've yourself, moderator, talked about this and how we need to think about how we deal with these issues, and then open science and open innovation. And then the last message that came is that you do need to think about robust governance of this global infrastructure. You need resources to do this and find better ways in which this funding has got to be harnessed, put together, and also, of course, be rationalized because the costs are getting higher and higher. You also need to manage your IPR very, very carefully and in a modern way. You also need political support. I think it also came from the previous presentation that unless sometimes we have the political support, and therefore as scientists we need to find a better balance between motivating for this infrastructure from the science return, but also on the societal and economic return. We need excellence-based access policies in order to have the scientists benefiting from this, and then I've already talked about data policies. And then, as I say, we also had the opportunity, very, very quickly, to showcase a project which we have, of course, with Australia hosting in Africa, and the impact of this project in the rest of the continent. We're not showing it because we are hosting this infrastructure, global infrastructure for the rest of the world, but I wanted to show this project because the sustainability of the advancement in the SKA project starting from the early 2000s was as a result of ICRI roadmap endorsing this as a project that scientists can develop over a period of time. So we had an opportunity, therefore, to showcase this project and the benefits, not only, of course, for the global community, but for the rest of the world, that it provides, for the Africa, that it provides development of research infrastructure in other African partner countries, and that it provides training of new skills, most importantly, not only for the astronomy community, radio astronomy in particular, but also for people outside the astronomy community in big data, for instance. So maybe those would be my opening remarks, and I'll be happy later to come and respond to your further questions. Thanks very much.
Thanks a lot, Phil. Thanks a lot. If I could sum up a little bit, in reality, all the main recommendations coming from ICRI 2016 are still valid in a minute, more than ever. But nevertheless, some progress took place, the discussion continued, and you have demonstrated again with the excellent example of SKA that indeed you have an added value and mutual benefit of this kind of international cooperation for any kind of partner. For different reasons, but reasons that are cumulated each other. Thanks a lot for this first interaction. Maybe a reaction on the side of the panelists on a particular point. Not yet? You are not warm enough? Okay, so let's continue with Kalina. Kalina, Bulgaria held the presidency of the Union a few months ago. It was in the first half of 2018. You put high on the agenda, in fact, of your presidency, research infrastructure, and in particular, you organized an event in Sofia where a number of issues were discussed, in particular, the sustainability. What were, if you could sum up with us, what were the main priorities of your presidency on research infrastructure, and to which extent they are valid also for this discussion, and how this event on ICRI could fulfill them?
Thank you very much, Jean-David, and I'm very honored to be in this panel, and congratulations to the Austrian presidency for this conference, and it's amazing to see so many people here. In fact, I'll comment on the previous speaker and like a small introduction to my intervention. In fact, we very much concentrated during our Bulgarian presidency on the European agenda for research infrastructures for the next decade, but in the same time I have to say that one of the main conclusions have been we should invest strongly, and we should build research infrastructures overall in the European Union locally. We should pay attention locally and nationally, but while being internationally, if I can transform it like this, because at the end of the day, if we are not open to the world, we can't measure our competitiveness. Indeed, the research infrastructures were high on our agenda, but I have to say that they are high on the agenda of the trio presidency, and I'm very happy that with the Austrian presidency we are working very much on the European research area. We prioritize research infrastructures because we were looking into the core elements, so to speak, in the building blocks of science, and we wanted very much to recognize the foundations of research and innovations, which basically are research infrastructures. And very often, while we are trying to be modern and to talk about future, for example, and to launch some new ideas like the missions, but in the same time we have fantastic landmarks which we have to recognize and to see how we can use their potential. So we work hardly on at the Council, and all the member states agree that the long-term sustainability is a huge priority. I must say this is not only because we put a lot of efforts. I have to say that the Commission did a fantastic job, and also ESFRI also contribute to this. Maybe you will recognize together with these political decisions that have been taken, that not only the funding and the financing is prerequisite for long-term sustainability. Okay, of course, it is usually the elephant in the room, and we discussed that we really need to align different financial mechanisms, not only to consolidate national and transnational funding, but also to consolidate different European program instruments, not only framework program, but now we are talking today for international cooperation, so we have development aids instruments, but we also have new instruments for digital agenda. And here is my second point that I want to stress very much today, and this is about the openness. In fact, the huge debates were mainly about how we can bring this openness of research infrastructures and to connect them more with the society, more with the economy, so that to make them not more adequate for the economies, but also to build a resilient future. And talking about this openness, of course, it's about data, about free movement of knowledge and data, which is extremely relevant topic also to look internationally, because Europe is pioneering in this area, and we can exchange very good cooperation with the world on this. We talk about, though, that if we want to be open, we should put more efforts to strengthen and to consolidate what we have in Europe, but also to connect all the dots that are existing in different regions, because in fact through research infrastructures we can better spread and utilize excellence in all over European Union and beyond. And here, as I have a colleague from my region, and I'm very proud that the Bulgarian government also is putting a lot of efforts not only on national roadmap, but also how we can unite efforts and transnational cooperation in the Western Balkan region concerning research infrastructures. And last but not least to say that obviously these Council conclusions that we adopt are a very good message to the politicians, because as the previous speakers today said, we need more than 30 years in order to show results, and we can't be stumble from barriers that sometimes we have. So we have to be future looking, and I hope that like this we a little bit shake and remind the politicians that we need to keep on investing in curiosity-driven and fundamental research, which is giving birth to the future innovations that we are talking. So briefly this, and I can make interventions later. Thank you.
Thanks a lot,
Thank you very
Karina.
much.
Are you warmer? Somebody would like to react on what Karina said? Some complementary points? Not yet? So let's move to the third panelist. We have the chance to have the Minister Sanja Tamjanovic with us. But it is in direct continuation with some of the points, in fact, that Karina mentioned a few minutes ago. I mean, you are fully aware, Minister, that for research infrastructure, investments could be substantial, especially when you are talking about development, construction, operating costs. It may be more than significant. Very often the pooling of different resources is necessary, and it was one of the topics that we discussed in particular in Sofia, and one of the conclusions of the EU Council that Karina mentioned. You are a policymaker, you are somebody who is driving and leading an initiative for research infrastructure covering multi-countries, and where by definition you are facing this kind of difficulties. According to you, and based on your experience, what are the drivers and the conditions for setting up a research infrastructure of a multinational level?
Thank you. So, ladies and gentlemen, it's a great pleasure for me to participate in this event. I wish to thank you for posing this question to me. Thinking about question, I felt the easiest way to answer is to use an example. So, my example is Southeast European International Institute for Sustainable Technologies, which most of you may not be aware of because it is in a very early stage. Do I change slide myself? Yes. Okay. So all of us know that real international cooperation bringing people together is the best way to accelerate knowledge and innovation, to enable the improvement of the living standard, and it is the most efficient way to assure sustainability. In more details, accelerating knowledge and innovation implies scientific excellence, education and training, transfer of technology, also boost of innovation. All that then can very much help improvement of the living standard because it can contribute to develop economy, to create new jobs, to trigger complementary technologies. Other important points here are science for peace, by keeping a dialogue between cultures, developing exchange of ideas, sharing all these common goals among the international partners. And another important point is science for society. Now coming to this third very important point, sustainability, this means ensuring the commitment of stakeholders with formal agreements, defining clearly the costs and operation model, minimizing environmental impact, and ensuring public acceptance. Now, the seized projects satisfy all these drivers and conditions which are mentioned here, but provides even more. Now, due to recent history, the Southeast Europe suffer very much. All scientific activities have very much slowed down. As a consequence, this region suffered ever since from a strong brain drain, affecting young generation, in particular the best one. But we should not forget that this region in the past had intensive technological development, and there are really plenty of great examples there. Therefore, the important mission of SEAST project is to revert the brain drain by enabling first-class research, and also to recover the great tradition which we had, to remedy the present desert of state-of-art infrastructure in this region. Another important task of this project is to mitigate tension between the countries in the region. Now, the combination of all these tasks would imply another case of CERN and SESAMI example of science for peace. Now coming to the forms of international cooperation, that can be ERIC, can be intergovernmental organization, others like association, but this will be defined during our next design study phase, which will be performed at CERN as the host. Now for SEAST project, multiple sources for financing will be necessary, and several are already considered, like contribution of EU Framework Program for Design study phase, and then EU structural cohesion funds, investments from member states, and also other funds, such as, for example, support from the International Atomic Energy Agency for training and education. Now, what is SEAST project? It is a facility for tumor therapy and biomedical research with protons and heavy ions. In this picture here, you see first machine in Europe, HIT Heidelberg, which started to operate in 2009, and by now they treated about 5,000 patients, 3,000 with carbon. Worldwide, 160,000 patients with protons and 25,000 with carbons. In Europe, there are 4 such machines. But SEAST is not going to be just 5th machine in Europe. SEAST is going to be unique in the world. Why? Because 50% of the time, of the beam time, will be dedicated to biomedical research, but with multi-ion sources beyond presently used proton and carbon ions. Even though 50% of time will be dedicated to research, we will still be able to treat about 500 patients, which is the need for population about 20 million. But look here, here's the map of sea region. So we are talking about a large integral part of Europe with about 40 million inhabitants with Greece, or 30 million without Greece. So within a very short time, we had a big success both on scientific and political scene. On political scene, declaration of intent has been already signed by 8 parties, and the signature was actually on the sand ground. And these are Albania, Bosnia and Herzegovina, Bulgaria, Kosovo, the former Yugoslav Republic of Macedonia, Montenegro, Serbia, and Slovenia. Croatia agreed at referendum, and Greece is presently an observer. Thank you.
Thank you, Minister. It's indeed a very, very interesting case, in fact. Not only because it's also a perfect illustration of science for diplomacy, as you said yourself, as a follow-up as a kind of initiatives that we have, for example, with Sesame, that you mentioned yourself. But it is also a research infrastructure where from the very beginning you are not only dealing with what is needed in terms of science, in terms of impact locally, but you are looking at the sustainability of the infrastructure from the beginning, and you have one dimension when you are dealing also with the revenues that can be created also by the infrastructure. So this is an interesting case because this is not necessarily the case for all our research infrastructure from the very beginning, for good reason. It's not a criticism here. So this is something maybe on which you could elaborate a bit more.
Okay, so thanks for this addressing this point. So I show you in my slides HIT Heidelberg, and this is a machine which is fully sustainable. Why? Because here you have a mixture of the sources. You have a Ministry of Science Education, but you have also Ministry of Health Insurances. So we already have example of fully sustainable machine. And also, if you think about 10 countries, it's very easy, even if you have those countries which have very small investment in research and innovation, still it's easy to handle that part. Being together and having international cooperation. I want another thing to address. Our region has a lot of sun. One of the part of operational cost is energy. So Sesame shows us how we can minimize the cost of the energy easily because we can create the solar power panels, and we are really thinking about sustainability from the first moment on. And also important, we are thinking about capacity building. And so already, thanks to Atomic Energy Agency, we have already from them support to do that, and we have time to build capacity. And as I mentioned, for sustainability, we are really thinking about from the first moment.
Thank you. Any reaction on the point of the Minister? Please, Sean.
Sure. One of the things I think the sustainability question raises is that, you know, during construction, everybody's very excited, sign up to collaborations, formal agreements, because they see opportunities for innovation and investment in their home countries, particularly if it's a large partnership. I think the thing that's really important to consider is that when we go into these projects, that we're always thinking about the current economic conditions, the current priorities. I think it's really important when we set up these collaborations and the agreements that we allow enough flexibility such that down the stretch, particularly when we're getting into the 10th year of operations or beyond, that we have enough flexibility in our agreements and structures to be able to accommodate changing economic conditions and changing national priorities.
To be able to adjust on real time.
Yeah.
Very important point. Any other remark on this presentation? Tony?
Yeah, well, a point which certainly also resonates, I think, with a bigger research organization in Europe is that you need to also have the national backing. What we indeed see is it's very easy to get brain drain, so involving the people from Southeastern Europe, that works in the beginning very much. At some point, all the young and brilliant scientists, they're working at the big centers further in Europe, and they don't come back. And then you see also that the interest or the involvement of the different countries is going down. And I think we need to do something there to have also this kind of national backing. So to keep the bright people there and to have the proper embedding. And I'm really inspired by your enthusiasm for this project.
Thank you. Somebody else? Ilaria.
This is on, yeah. I thought this presentation and what was said, one of the outcomes that was evident is in the transformation that these endeavors actually bring into the society. and how we are organized politically, organizationally, economically, scientifically, but how we work together. And these endeavors really are, we've experienced it ourselves in the construction of EMBRC. These endeavors are transformative, and the landscape is not the same after this effort has been made. And you will find that with pooling of resources, you have, of course, economic viability that is higher, but the pooling of resources will bring along the pooling of mind resources, of brains, and thinking together. I think this is an ultimate goal for any endeavors of those, to be able to not just pool physical resources in some place, but pool the minds together, as you are also pointing, to recover the intellectual abilities and think of dreams that we may have not thought before as single individual, because we just are maybe practical and we realize that we cannot afford to go somewhere so far alone.
Thank you, Ilaria. Phil.
Yeah, thanks very much. I'm not sure what the other panel members would talk about, but I hope that in this discussion of the interface between global research infrastructure, politics and funding, we probably have an opportunity to remember that some of these global infrastructures are addressing the sustainable development goals. And I haven't had anyone talking about how sometimes the way that we put together the global research infrastructure address some of the sustainable development goals, including the framework of how we as scientists need to remember and ensure that we are relevant to those. I do know that there is Barbara Ryan, who used to be the director of the GEOS in Geneva, and she will talk about how, for instance, the global research infrastructure in the space arena has been put together to specifically identify areas of sustainable goals where the space sector, for instance, working globally can address some of those and contribute to those.
Thanks a lot to recall and remind us that this is also a very important issue. Any other remark on this point? If not, I propose that we move to Sean. Sean, you are a practitioner in reality. I mean, you are the Director General of ALMA. And as a consequence, you are directly confronted to one key dimension, which is how to ensure the proper integration of research infrastructure in a local ecosystem. I'm asking the question, of course, to you for reasons that you fully understand, but this could be expanded, of course, globally. Can you share your views on this?
Yeah, this is it's a good question, and I think in Chile we have some experience to answer it. So, for those of you that don't know what ALMA is, this is the ALMA telescope. It is the largest telescope in the world currently, although Phil and co are pushing hard to change that. It's an extraordinary piece of technology. Each of those antennas, there are 66 of them, have a surface accuracy that is about 1/10 of a hair on your head, okay? And they're in an environment where the wind speed is often in excess of 100 kilometers an hour. It's quite an extraordinary achievement, human achievement, to build this antenna. And it's really a success because of the collaboration between the European Southern Observatory, representing the member states here in Europe, the National Institute of Natural Sciences in Japan, and the National Science Foundation in the US. A complex infrastructure of this type in an extraordinary location as this is, which is at 5,000 meters in the Chilean, the high Andes of the northern Chile. It takes an extraordinary amount of expertise, which we have to draw on from multiple countries, and it requires a funding model that no one country could sustain. So I think this is an excellent example of a very successful collaboration that stretches across the globe, principally through these three organizations. And putting it in the Chilean desert, It is the best place in the world aside from the South Pole, but we won't go to the South Pole because that's an even more extraordinary place. It's very remote, and so it's presented a number of problems to us. But it's remote to us in the sense of it takes a lot of effort to get the facility built in this location, but it's not remote to the Chileans. This land has been used for centuries by the local indigenous people, and it offers some very unique environmental challenges in placing that infrastructure there, because the altitude change of the concession goes from just shy of 2,000 meters all the way up to 5,000 meters. We have over 100 kilometers of road that we have to, in place, and that has presented a whole bunch of environmental issues that we had to address. Those were the principal challenges in Chile, and I think we were very fortunate in the sense that ESO particularly has over 50 years of experience in Chile, and we certainly leveraged that experience extensively, but also the NSF and NINS had built facilities in Chile as well. And I think that really aided the process of putting the telescope together in northern Chile. But let's focus on the challenges that we faced. That's what Jean-David asked me to. I just couldn't resist putting a picture in of what the night sky in Chile looks like for you. You can really sense that you could touch the stars if you reached up. That's how clear it is. The first thing we did was we voluntarily did an impact study related to the environment and to the potential archaeological impacts. That was done, and the mitigating strategies were arranged in collaboration with the Chilean authorities. We continue today to monitor both the bio concerns and the archaeological concerns on a very regular basis. And speaking to a point that Phil raised was there's worrying about the societal development. We work extensively with the local authorities. We do a lot of promotion of socioeconomic initiatives in the region. To date, this is just shy of $5 million of funds. And these funds are managed completely by the local region. We don't have anything to do with it once the money's gone. And these projects of taking care of such things as installing solar panels to heat water for the local town of Tocanao. The funds helped to install a movie theater in San Pedro. The funds have been used to reinvigorate a vineyard that had long fallen into disrepair, and so now they're producing wine again. You have to appreciate that this is a very impoverished area of Chile, and really it survives, I think is the right word, on tourism principally. And so all these small, the things that $5 million can do actually make a huge impact locally. And the other thing we've done is we've sponsored education in the area, and this has had a very noticeable effect. One of the local schools where we support the English and science programs was recently in an exam test was one of the top 100 schools in Chile, which is extraordinary from a school in such a remote area who didn't have access to materials and experimental equipment and so forth without the aid of this program. This has been a great success. So thinking more about what was the benefits that we were able to give to Chile, many of you probably appreciate Chile is very much, its economy is very much based around resources, around copper in particular. And so diversification is something that they're really keen on. And certainly high-tech infrastructure such as ALMA is a key part of trying to diversify. And particularly in Chile, all the observatories, all of us, 10% of the observing time goes to Chilean astronomers. So that's developing Chilean astronomy. We've allocated to date something just shy of $10 million in promoting specialized training, particularly in engineering and in science. And that's mostly to the university system. That's reaping benefits that we can readily see. the Universidad de Chile, they've participated in building one of our new detector systems that just went on the sky recently, Band 5, and they worked with colleagues in Taiwan in developing a new system, new detector system called Band 1. The other thing is many universities are taking advantage of the location at 5,000 meters as an excellent place to study the issues related to medicine at high altitude. The Universidad de Chile and even universities from much further afield. My own alma mater, the University of Calgary, has had an extensive program running there for the last 5 years studying the effects of edema. Now, the other thing that's relatively new is that the Chilean government has realized there's an opportunity that presents itself largely because of the astronomy infrastructure in the country. ALMA is just the latest. The ESO ELT is coming. ESO has observatories at Paranal and at La Silla, and NSF has facilities close to La Serena. And the Chilean government is very keen to take advantage of this and use it as a driver for developing data science and informatics. And I think this is also a point that Phil raised in terms of data management. And this is, I think, going to be a very big story in Chile over the coming years, as the government are extremely keen to promote this. Also, because of the observatories, that's been a boon to the development of the telecommunications system across the country. Paranal near Antofagasta basically drove the development of the fiber connection from Antofagasta to La Serena and on to Santiago. And ALMA's development drove the installation of another fiber link from Calama to Antofagasta. So now the infrastructure in the north of the country in particular has really advanced, solely driven by the development of those facilities in that part of the country. And of course, there are the direct benefits. 240 of our staff are Chileans, out of a total of 270 staff. And lastly, as a director, one of the things I find most heartwarming is when I get into an Uber or a taxi in Santiago and I get asked what it is that I do for a living, and I mention ALMA. Chileans have an immense sense of national pride due to that facility. And I think we should not underestimate the power of that. It takes some effort, I think, to get there, and I think things like public outreach and education and all those educational programs are an important part of that. But I think it's an enormously I think if somebody can say, yeah, we're really proud of having this facility in our country, I think you can say you've done very well in integrating yourself into that society.
Thanks a lot, Sean. Really a great example of how a research infrastructure can have a local impact on many dimensions, including the socio-economic one, as you perfectly mentioned it, of course, on the scientific dimension. Maybe some reaction on the side of Phil or Sonia? Because you are confronted to something similar.
I really enjoy listening to your slides, and I would like that my talk was after yours. It would be really easier for me. But this is exactly what we want to do. I mean, the only way, as I said, to bring back our people is to offer first-class research, and that will trigger development of economy. And I mean, your example is what I would like to see in Southeast Europe.
Karina.
Thank you. It's an amazing presentation. I first heard from Chile when one young Bulgarian boy, 16 years old, won a fellowship there, and he never came back, in fact, but it doesn't matter. This is not important. I don't like to talk for when we talk brain drain, to talk about we should keep the people here. We should just talk how to attract people, and I'm very happy that you show the example how to integrate in the local mindset, economy and society such an infrastructure with international dimension. I mean, this should be our overall goal also of the European Union, but also of on the global scene. But what I think is very important, and we saw with all these examples, is that research infrastructures are unique and very different. This is something that I wanted to stress earlier. So, of course, we have to build, give a bit more trust when we are building new infrastructures, because they are different and we can't expect that everywhere we will build something like AUMA. But for sure, we should keep the same standards, especially concerning STEM education, open access, standards for archiving data, and knowledge exchange. This is my reflection. Thank you.
Thank you, Karina. No particular reaction on this. I think it's indeed an important element that we have also to take into consideration. I propose to move to Tony. So, CERN, EMBL, ESRF, ELL, more recently XFEL, are creating, in fact, the Aero Forum. Of course, here we are talking about big infrastructures. You have a very important knowledge on how to setting policy agenda on research infrastructures. Can you share with us what lessons you have learned on this area first, and if you allow me to expand also what lessons this kind of big infrastructure and big organization or this kind of lessons they learn, how they can give some advice to other research infrastructures, because of course we are always talking about the biggest one, but the huge majority of research infrastructure are smaller or more local, and they have also a key role to play in the environmental landscape. So if you could share with us your views, Tony.
Thank you. I didn't prepare slides, so I read myself, so you don't have to read. So to be sure that we didn't miss any of the IROs, let me shortly introduce. So IRO Forum is a partnership of the 8 largest research organizations, all intergovernmental in Europe. So let me only give you the acronyms because probably you know them all. CERN, EMBL, ESA, ESO, ESRF, XFEL, ILL and Eurofusion. Eurofusion, that's the one I have the honor to lead since 2014, and we now have also the rotational chairmanship of IRO Forum. That's why I'm here. We were established in 2002, and we have 16 years of collective experience in design, establishment, construction, operation, upgrade of major international research infrastructures. And some of these infrastructures, they have been included on the ICRI roadmap, and we are still involved in coordinating or participating in a number of these ICRI projects and to use our know-how and experience to facilitate the development. The participating research infrastructures in IRO Forum demonstrate what can be achieved together when countries commit to collaborative research projects that offer a size that cannot be afforded by any single country. And we are strongly focused on basic curiosity-driven research to extend the frontiers of knowledge, but the benefits of IRO Forum and these research infrastructures go well beyond the expansion of scientific knowledge. One example, it has been already mentioned, it provides an excellent training opportunity for young researchers, for engineers, for technicians, and the majority of them find easy employment in other research infrastructures, in education, but also in industry, in SMEs as well as in SMIs. And talking about industry, if you really want to establish large scientific infrastructures, let's name a few: the Large Hadron Collider, the extremely large telescope, the International Space Station, the ITER fusion reactor, the European XFEL. You can only do this in very close interaction with industry. And the very precise instruments we have seen the talk about LIGO and Virgo, they demand an extremely high level of innovation from the industry, and this often leads to new products and spin-offs into completely different markets you didn't foresee before. Think about the World Wide Web. It was already mentioned by Phil, a spin-off from CERN. The development of superconducting cables for fusion have led to an enormous spin-off in magnetic resonance imaging, a multi-billion enterprise per year. The treatment of cancer, new methods which have been developed. And looking forward, the pioneering concept of co-innovation ecosystem between fundamental research and industrial communities to develop breakthrough detection and imaging technologies for scientific and commercial uses has just been launched as the ATTRACT project. This is a project which is funded by Horizon 2020. It is driven by a number of the IRA Forum organizations, and it aims to provide a bigger return on Europe's scientific investment that will benefit both economy and society at large. And although we are researching in very different fields of science, from nanophotonics, biology, fusion, astrophysics, high energy physics, we all deal with big data. Also that has been mentioned. So petabytes of scale, sometimes in seconds. The need for open access of publications and data because we are using taxpayer money, and of course personal and governance issues. If I look back to these 16 years, we have shown the importance and value of strong political commitment to fundamental scientific research in the form of international treaties with sustainable governance and funding structures, interdisciplinary research, cooperation at an international level, and also to show how research-driven innovation impacts society at many levels. So coming to your question, to what are the lessons, what can be learned for the small research infrastructures, I would say that first of all they need to ensure excellence in science. They need to address the needs of the scientific community and remain at the forefront of the field. Have a long-term planning, so also think longer than just a building period, but also what happens after 10 years. And a strategy to keep the societal impact in mind and ensure an exchange of expertise on all levels. Let me close by saying one important achievement. Over the years, IRA Forum has driven innovation. I have given some examples already. This impact is the ultimate justification also for doing basic research. Sometimes we don't know what we find, but very often we find innovations and surprises, and this research impacts society down to the individual level and changes the lives of many to the better. Thank you.
Thanks a lot, Tony. A particular reaction on the point addressed by Tony? No? Ilaria. So we met together a few months ago at a very important moment for you. You were the executive director of a newly created infrastructure called the European Marine Biological Resource Center, and it's an ERIC. It's a distributed research infrastructure with 9 countries, and you are indeed using the ERIC status. A lot of people in the room maybe do not know what is an ERIC status. And this is why, can you explain to us, and especially for an international audience, what were for you the biggest challenges that you faced to become an ERIC, explaining what is the interest of an ERIC, of course, and how you addressed in this context the issue of the long-term sustainability, which was at the heart, of course, of your candidature. Ilaria.
I will just...
Please, please.
I don't have a presentation. I want to. So thank you very much for the opportunity to share our experiences with this magnificent crowd and this magnificent opportunity. Thank you very much to the organizers and the European Commission for having us. As Jean-David just told us, EMBRC is a newly established research infrastructure. We're humbled, perhaps, by much bigger endeavors that are typical of the physical or astronomical domain. However, the marine, the oceans, today have an immense, let's say, like they carry a promise, they carry an opportunity for all of us. And in this sense, our infrastructure is very fortunate to be exactly in this domain working and trying to facilitate or shortcut, perhaps, the road to some solutions for global challenges which are in the climate, in the energy, in the health provision, and food, of course. The marine is a transversal domain, and we can talk for hours about what kind of challenges it allows us to address. And you can only think that there are some very peculiar situations or where you would not expect the marine to be coming into play, but drug delivery systems or therapeutics for cancer or new ways to produce elements that are fundamental for our well-being. In all this, marine resources really hold a key that was hidden until now, because what we say is that the oceans are the ultimate inner frontier. So we haven't gone up the space, or actually we've seen a few of the space objects quite close, but the oceans is virtually unexplored. So there is a lot to take home from this. We have come together as a community of scientists and administrators and public authorities to work on these challenges and work together. We have taken 10 years to get here. So regardless of the size of the investment, we still have faced, I guess, the challenges that all endeavors face, which are in this establishment of common frameworks of operation, of common ways to think about how to deliver a project like this. So the ERIC was one instrument that the Commission offered to actually put these minds together and this investment together into an object that could work in the world to deliver. So the ERIC is the European Research Infrastructure Consortium. It's just a form of a company, if you want. It's a form of association. It's like a limited company or an object that has an economic or a juridical personality, a legal entity. So that is an ERIC. Then there are ERICs that have different names, EMBRC, and EMSO, and EU Open Screen. We are 18 today. So what was the challenge in getting to this status? As we heard earlier this morning, we were in a workshop with the Commission and with ICRI, which is the European Strategic Forum for Research Infrastructures. There are different schemes, or there are different ways you can organize yourself to achieve this legal entity status. However, the ERIC is one that really impersonates this pan-European interest to materialize and deliver an objective. And that gives the entity an international status. So these are very appealing elements to us because we want to play in the international arena. We want to be a resource that is globally identified. So what the specific challenges were, as I said, I think that we share those challenges with most of the endeavors bringing an initiative into the world. And I would say that governance and the complex nature of the ERIC are two important aspects to take into consideration. Why is the ERIC a complex object? Because we are something in between public and private. We're a public and private partnership, and some stakeholders may not even fully recognize this, because it's difficult for the public mind to think that they're actually entering a private endeavor, because the ICRI, in fact, is a private association at the end of the day, although it is publicly recognized, so it's complex. And then we have this tension between the central management and the national dimension of the infrastructure, which in our case is distributed, which means there is a central coordination point, and then in various countries of Europe, we have stations, research stations or research centers. So there is a tension there to be resolved. But also there is another fundamental question about science and administration, science and science management, or management of the infrastructure. Management of the infrastructure and science are not necessarily the same thing. And we need to constantly be able to bridge these languages. The other language that needs to be translated or bridged is the industry-science relationship. All these domains are virtually the mirror of the other, or say the opposite in that, that's what I mean. And so the effort is always to keep this tension, not to break it, but to make it work in a positive way to find a solution. So I would say that one element that brought us to consensus and that addresses the long-term sustainability, which in fact at the end of the day is key to convince your stakeholders that your project is viable, is worth for them to invest their monies into this, and their time and their efforts and their resources. The business plan of EMBRC ICRI, which has been regarded as an example for the community of the ICRIs, and of which we are extremely proud, and which costed us a lot of energy. But that element brings us into understanding the various parts of this endeavor, and therefore to valorize them in the right way. And so I will leave it to this, and if there are questions, we can talk about it.
Many thanks for sharing this with us, Ilaria. Any question to Ilaria or reaction on this? No, so I propose, because we are almost late, I'm looking at the organizer, so I will go to the last panelist. I promise, Daniel, I will not be too late. Luca, you are coordinating a project on cultural heritage. It's called the European Research Infrastructure for Heritage Science. It is a project that has been included in the S3 roadmap in 2016. We would be pleased to listen to you on your experience on the key issues, according to you, for turning such a project, which was initiated in Europe, into a global initiative. Please. What are the obstacles you face? What kind of legal framework you think about? What are your experience with this?
Thank you, Jean-David. I confess that I'm still trying to feel fantastic, magnificent, as you said, but doesn't come in this easy. If Ilaria is feeling small in this company, I am feeling even smaller, because we are a very recent project. We entered 2016. And actually we just reached we are halfway the preparatory phase towards an ICRI. So I can only try to tell the history why we are here. Not just a coincidence, because this year is the European Year of Cultural Heritage, and we are committed to that. Well, everything started in 2013. There was the date of a forum on conservation science, an international forum on conservation science, organized by the Intergovernmental Organization for Study and Preservation of Cultural Heritage, ICRI. At that time, we were an integrating activity in Europe. And we started feeling that we had a global mission, in the sense that preservation study, conservation of heritage, is not a European concern, it's a global concern. And also, we know, working in the field, that we have already international cooperation outside Europe. And in this sense, I heard Europe being defined a culture superpower. Yeah, it's a responsibility, especially to maintain the status of a superpower, you need to invest. And heritage science is not one of the fields where a lot of research money usually goes. Anyway, so we started before submitting ICRI. We answered the questionnaire to the group of senior officials why we should have been considered as a potential global distributed research infrastructure. And we are still under discussion as a potential candidate. Soon after, we realized that it was a bit tricky to start with global ideas, and maybe also a stupid thing. And so we split the problem in two. We have surely a long roadmap in front of us. So step one, ramping up from integrating activity to the ERIC status, already described by Ilaria. Step two, ramping up from the ERIC to the global activity, maybe pointing to a global distributed infrastructure. In this process, we just started step one. So I cannot give advices about how we have ideas how to go to step two, but we need to wait. One of the big issues is that step two, so international cooperation usually starts with bilateral, multilateral agreements. So you need to have the power of writing agreements, signing agreements, and so you need a status. And so this is why we are pointing first to sounding and safely establish IRIs in Europe, which is already a big piece of work, because currently we have 20 European states which are observing the preparatory phase, and so we have a lot of negotiation going on, we have a lot of discussion, as you can imagine. And in the meantime, we are not forgetting that we are this mission as a potential global infrastructure, so we keep on an intense activity of international cooperation. In the next 3 months, we will have a transnational discussion workshop in San Francisco during Digital Heritage. We will have a meeting in Brazil with the interest group of IRIS in Brazil, and in December we will have a meeting in Mexico City with not just Mexico, but several countries involved there. And so we are also engaged in keeping this idea of be ready, because when we will be an ERIC, maybe in 2021, 2022, we will really start doing something, something practical also. What is the idea? The final idea, I don't know. Pointing directly to an international organization, it could be really complex and time-consuming. So I'm not guaranteed that we will choose that. I think that we will decide during the process. What is a good starting point, and I cite it here because it happened last week. We signed last week a statement of cooperation with ICRI. So it was difficult to find a legal figure under which to sign. We signed it under the legal form of European project, and we will translate this agreement when we will have the governance for the transition phase. Thank you.
Thank you, Luca. Thanks a lot. This brings us to the end of this session. I'm looking at Daniel. I have to close the session. I just would like to thank you all of you. I mean, you have heard different stage of development of research infrastructure, from the very initial stage to some that are very well established, but all of them with a clear commitment that indeed they can make a change on scientific matters, on socioeconomic matters, on economic matters, dealing at their level, of course, to a number of sustainable development goals that you rightly remember, Phil. You see also a clear political willingness on a number of countries of different moments. So there is a willingness, an appetite to do much more on research infrastructure and in particular also at global level. I think it was a very good start for this conference, and I just would like that you applaud all our panelists this afternoon. Thanks again.
Thank you very much. Thank you very much, Jean-David. Thank you very much to the great panelists of the first plenary session. Timekeeping is always a little bit difficult, but we will manage it. We just make your coffee break a little bit shorter. So instead of 30 minutes, you have 15 minutes. Enjoy coffee outside, and please come back 20 minutes to 4 at the latest. We will have some music here in the room, and when the music ends, then the next plenary session will start. Enjoy your coffee.